Imagine taking the sun, yes, the sun, or any star whose mass is equivalent to the mass of the sun, and keep squeezing it, squashing it, and collapsing it until its radius is equivalent to 3 kilometers. I know that sounds like sci-fi, right? But the mind-blowing part of it is that the gravitational pull on the surface of that body would be so intense that the escape velocity required to escape that gravitational pull would far exceed the speed of light. That means that the light rays themselves wouldn't be able to escape that gravitational pull. Well, I know that sounds unreal still, but that is a black hole. A place in space where reality as we know it breaks and the escape velocity far exceeds the speed of light and the laws that govern the physics of the universe cease to operate. Well, if you're new here, my name is Aroseth, and on this channel we dive deep into the worlds of tech, physics, and personal development, all tailored together to spark curiosity, innovation, and empower your journey into a more meaningful, purposeful, and productive life. So if that resonates with you, please consider subscribing. And in this video, we're going to dive deep into the hottest and interesting topic: what is a black hole and what happens if you fall into the black hole. So if that resonates with you, please turn the phone into landscape mode and let's get into it. Timestamps are going to be linked down below, and feel free to skip around the video in case you want to do so. So, what is a black hole? A black hole is an astronomical object whose gravitational pull is so strong that nothing would be able to escape that gravitational pull. But how are black holes detected? Now, on 22nd of November 2014, a burst of X-rays was detected by the Assassin, that is, all-sky automated survey for supernovae, but it was no supernova. A signal came from the center of a galaxy that is 290 million light years away. And what you believe that happened is that a star came closer to a very supermassive black hole whose mass is 1,000,000 times the mass of the sun, and the black hole fed on that star. Yeah, that is the right term that is used by the astrophysicists. The star was eaten by the black hole. Events like these are rare to happen. They are called the tidal disruption flares or the tidal disruption events. As the star came closer to the black hole, the side of the star that was so close to the black hole experienced a very huge gravitational pull, thus the star being pulled towards the black hole and being eaten up. Now, this event caused the accretion disk, which is an annular ring of gas and dust that is always surrounding a black hole, which emitted visible light, UV, and X-rays that were later on detected on Earth. Now, what's remarkable is that this event turned a dominant, quiet black hole into a visible black hole that was able to be detected from Earth. So how big are black holes? Now, one of the smallest black holes that has ever been detected is the J1650. It has the diameter equivalent to Manhattan and the mass equivalent to 3.8 times the mass of the sun. One step up would be the Messier 15, whose diameter is twice the diameter of the sun, and the mass is 4,000 times the mass of the Earth, of the sun. And just after that is the Sagittarius S star, whose mass is 100,000 times the mass of the sun. Then here comes the M87 that weighs 5.4 billion times the sun. You would fit about 4 galaxies inside it, and it was first detected in 2019. And this one is one of the biggest, the TAN 618, which weighs 66 billion times the mass of the sun. And you would be able to fit 40 solar systems into that black hole. But that is not the biggest. There is the Phoenix A, which seems to weigh 100 billion times the mass of the sun. And I'm sure those are not the only ones we know. There are some that are there that are waiting for us to detect them. Now, this is the question: what happens if you fall into a black hole? Now, the effects of the black hole continue to escalate as the object approaches the event horizon. This is the point of no return, beyond which not any object, not even light rays, can be able to escape. Now, for many objects that fall into the black hole, the gravitational pull in the black hole continues to grow stronger and stronger, and the object continues to grow thinner and longer. That means that the black hole's gravitational pull continues to pull your body atoms apart as it is pushing you or squeezing you into a small, tiny object. To my understanding of this, when the gravitational pull at the bottom of the body is different from the gravitational pull at the top of the body, the object grows longer and thinner and starts breaking down. The atoms start disintegrating until the point reaches the point of singularity. Now, this process was first described by a scientist called Stephen Hawking, and he termed this process as spaghettification. This is because as the black hole's gravity pulls you apart, and thus being thinner and longer, you turn into spaghetti. Thus the term spaghettification. But the black hole does not only turn you into spaghetti, it also squeezes you until you become like a pancake. Thus the term pancake detonation. Because as the body elongates, the gravitational pull also continues to push you closer and closer until you turn into a pancake, but as long as a spaghetti. Thus the terms spaghettification and pancake detonation. Now, in addition to that, as the body is falling into the black hole, time would actually also change. The time of that body would actually move slower than the time of the person or the observer that is outside the black hole. Why does that happen? This is because supermassive objects like black holes create a very strong gravitational field on the space-time fabric, thus creating a very strong curvature, hence increasing the time dilation. We actually also experience a time dilation on Earth, only that it is always smaller compared to other supermassive bodies. This is because we exert a very small curvature on the space-time fabric, thus causing that small dilation. Now, it is also detected by the people who actually fly in planes that time actually ticks faster when you're landing or when you're still on Earth than during when the plane is high in the sky. So when you fall into a black hole, time will start moving slower for you compared to the person who is actually far from the black hole or observing from the Earth. So where does this body end to? Now, after the body is disintegrated into atoms, and atoms disintegrate into protons and quarks, so what happens? All these protons and quarks go to the point called the point of singularity. Now, this is the center of the black hole, where space and time are infinitely curved and where the laws of physics cease to operate. Now, since the black hole is the distortion of space and time, the point of singularity is not just a point, but it's also a moment in time. And according to the Einstein's theory, he suggests that it's the end of time. So can you ever get out of the black hole? Well, according to Einstein, he suggests that nothing can ever get out of the black hole after it has collapsed in. But Stephen Hawking later on suggested that actually what happens is that those protons and quarks and atoms that fell into the black hole later on are emitted as the Hawking's radiation. Now, the Hawking radiation are particles being emitted from the black hole due to the matter that was eaten up by the black hole. It has high temperatures and it's always glowing. That means that it is always losing energy, which means that at some point it will later on lose all the energy and get back to normal. But what does that mean? It means that all the matter would be passed out from the event horizon and all the data would be erased. But there's something that was missing in the Hawking's calculation. He suggested that the radiation that was moving out of the black hole was information free. That means that it was purely thermal and there is no record that anything has actually ever fallen into the black hole. That means that all the data is erased. But the laws of nature suggest that information can never be destroyed. It can be dismantled, but it can never be destroyed. Therefore, that means that the Hawking calculation was somehow losing on it at some point. Later on in 2019, papers were published that suggested that the Hawking radiation that actually gets out of the black hole contains the imprinted information of the things that actually fell into the black hole, to the extent that if you were able to collect back the radiation and put it together, you would actually know what fell in the black hole and know all the information that was about that object that fell into the black hole. Now, black holes are very interesting because they stretch the limits of our understanding of nature and they really excite the creativity of physicists. In their strangeness and extremeness, they show us the hidden reality of the universe, thus keeping our minds blown and yearning for more answers and answers. So if you've watched up this point, I want to thank you very much. I hope you got a basic understanding of what a black hole is. And I want to say that if you are really interested in this topic, feel free to check other videos in my physics club or tech club, and feel free to comment anything in the comment section that you'd like me to talk about in the upcoming videos. Thank you for watching and see you next time. Bye bye.